Hello, in this video we solve a simple problem. Consider a surface of revolution defined through this surface patch sigma of u comma v. Here it is given as f of u cos v, f of u sin v, g of u, such that f of u is greater than 0 for all the values of u, and the profile curve u is given by f of u comma 0 comma gu, which is a unit speed curve. Then find the second fundamental form for the surface of unit sphere and surface of unit cylinder. For that, first let's write the definition of second fundamental form. So what is the definition for second fundamental form? So definition is given by L du square 2m du dv plus n dv square. So here u and v are the parameters of the surface. What is L? So L is defined as sigma u. So second derivative with respect to u, sigma of the surface patch, with n. N is the standard unit normal. What is m? M is given by sigma uv. So second derivative with respect to u and v, and unit n dotted with n vector, standard unit normal. What is capital N? Parameter. Here it is given by sigma vv dot n. So what is n? N is the standard unit normal on the surface, perpendicular to the surface. So standard unit normal is obtained, it's defined as sigma u cross sigma v divided by the magnitude of this vector. This gives the unit vector. Okay, so we know what is sigma of u comma v is. What is this? This is f of u cos v, f of u sin v, g of u. From this we can find what is sigma of u. What is sigma of u? It is f dot u cos v, f dot u sin v, and g dot u. What is this is first derivative with respect to u. F dot u is the first derivative with respect to u. F dot means here derivative with respect to u. So what is sigma uu? Second derivative. So we can find from here is f double dot u cos v, f double dot u sin v, g double dot u. This is for second derivative. Let's find out what is sigma of v. Sigma v is, so minus f of u sin v, first derivative with respect to v. So f of u cos v, this is 0 because there is no expression with v variable. What is sigma of vv? This is minus f of u cos v minus f of u sin v comma 0. So the last one, what is sigma of uv? U of v is f dot u sin v, f dot u cos v 0. There is no derivative with respect to v here with sigma of u, uv. It's a first derivative with respect to v. sigma u, then again take the derivative with respect to v, you'll get sigma uv. So we have all the ingredients. Now first let's find out what is n. N is sigma u cross sigma v, it is, and divided by the magnitude. What is sigma u and sigma v? So we can write it in a determinant form to find the cross product. So let's take I, j, k. What is sigma of u? F dot u cos v, f dot u sin v, g dot u. And what is sigma v? Minus f of u sin v, f of u cos v, 0. So what is this vector you get for n? Not the n, this is, we are not dividing by magnitude now, so we are just finding this quantity sigma u cross sigma v. So what is sigma u cross sigma v? The first component comes from here, this is minus f of u g dot u cos v. What is the second component? You get minus of f of u sin v g dot u, right? The final component is f of u f dot u. So this is sigma u cross sigma v. So what is the magnitude of this? Sigma u cross sigma v, the norm, what is the norm of this vector? Take the square root, multiply with the same quantity, take the square of each component and add them. So from here you can see these two guys will combine. There is f of u common, so let's take f square u outside, and then you have g dot square u, which combines with cos square v, cos plus sin square v gives 1. Then you have one more here, f dot u square. So you get f of u square root of g dot square u plus f dot square u, right? This is the magnitude of sigma cross u and sigma cross v. So after that, what we need is here in the question it is given that this is a unit speed curve. So gamma, let's define that unit speed curve. Gamma f of u comma 0 comma gu is a unit speed curve. What does it mean? That magnitude of gamma dot, this is equal to 1. So what is the norm of the gamma dot? Norm of the gamma dot is f dot of u square plus g dot of u square is equal to 1. This is given in the question. So therefore our sigma cross v, u, so this must be u and sigma cross b, this is equal to f of u, because this quantity is 1. So what we can, when we divide sigma u cross sigma v by its norm, these f of u will cancel, right? From each term you can get rid of f of u. So what is the standard unit normal will be? Minus g dot u cos v minus g dot u sin v, comma last f dot u. This is the expression for standard unit normal. Now let's find out what L is. We have everything now. What is L is sigma uu dot n. What is sigma uu? It is f double dot u cos v, f double dot u sin v, comma g double dot u. This is dotted with this n vector minus g dot u cos v minus g dot u sin v f dot u. So when you take the dot product, so multiply with the components, what do you get? F double dot u minus, there is sigma uu, there is a sign mistake. Okay, what is n? N is correct, right? Yeah. This is correct. Did we do anything wrong? No. Okay, cos square v f double dot g dot u cos square v. No, we are correct. F dot u g dot u sin square v plus f dot u g double dot u. These two will combine because we have cos square v and sin square v. So we get minus f double dot u g dot u plus f dot u g double dot u. This is our n l. So let's find out what is m. M is sigma uv dot n. What is sigma uv? Sigma uv is minus f dot u sin v, then f dot u cos v, right? And this is 0. And what is n? N here it is given by minus g dot u cos v minus g dot u sin v comma f dot u. So what you get from here is g dot u f dot u cos v sin v minus g dot u f dot u cos v sin v, and this is 0. So sorry, plus 0. So these two cancels again, then you get m equal to 0. So what is n? Sigma vv dot n unit normal. Sigma vv is given by minus f of u cos v minus f of u sin v comma 0, and this is g dot u cos v minus g dot u sin v comma 0. So this is dot product. Once you take the dot product, you get f of u g dot u. This is n. So at the end we can write what is the second fundamental form. This is f dot u g double dot u minus f double dot u g dot u du square. M is 0, so f of u g dot u is dv square. This is L, this is n. So this is L, this is n. So this is the second fundamental form, and for unit sphere we'll take u equal to, for unit sphere we'll take u equal to theta, v equal to phi, f of u is equal to what we will take, cos u, g of u we will take sin u. So what we are going to get, from this expression, the first expression f dot u is sine minus sine u. Sine, here u is theta, right? Sine theta. This is sine theta. Okay. We'll write f of theta as cos theta and g of theta as sine theta, and f dot is minus sine theta, g double dot is cos theta, and again minus, you will get sine square theta. F double dot is minus sine theta and minus cos theta, so again f double dot, g dot is cos theta, so you will get plus cos square theta, so this is d theta square. Here f of u, g dot, f of u is cos, g dot of u is again cos, so you will get cos square theta d phi. So what is the second fundamental form? D theta square plus cos square theta d phi square. So you can see from this expression is that theta and phi are the eigen directions for the second fundamental form. So we don't have the component of m, so theta and phi are the eigen directions of the curvature. So for unit cylinder, we'll take u is equal to, what we should take, theta, v is equal to phi, f of theta is 1, g of theta is theta. So what we get, L equal to 0, m equal to 0, because here we have double dot, right? F dot, it's a constant, here it goes 0, f double dot it also constant, so f of theta is 1, so L becomes 0, m is anyway 0. For n, here you can see this is 1, this is also 1, so you will get n equal to 1. So the second fundamental form for unit cylinder is just d phi square. So it has only the curvature along phi direction. That's the interpretation. Okay, thank you.